Hello students, welcome to lecture series of Mathematics 1. This is Hitesh Monglani, Assistant Professor at LJ Institute of Engineering and Technology. Today we will discuss Unit 3, that is partial derivatives. Partial derivatives. So what is partial derivative? So whenever function is of two variables or more than two variables, then we will use partial derivative. And whenever function is of one variable, then we will use ordinary derivative. So here in this unit, first topic is limit and continuity of functions of several variables. So here first of all we will discuss limit with the help of example. So let us discuss first example. Find limit xy tends to 1, 2 where function is x square y cube minus x cube y square plus 3x plus 2y. Okay, so here we will replace x by 1 and y by 2 in the function. So here simply replacing x by 1 and y by 2. So here it will be 1 square into 2 cube minus 1 cube into 2 square plus 3 into 1 plus 2 into 2. So if we simplify this, then here it will be 1 square, that is 1, and 2 cube is 8. So 1 into 8, that is 8, minus 1 into 4, because 2 square is 4, so it will be minus 4, then plus 3 and plus 4. So this will be 11, because 4 cancel out, 8 plus 3, that is 11. So this is answer of this question. Now we will discuss second example related to limit, that is limit xy tends to 0, 0 and the function is x raised to 4 minus y square divided by x raised to 4 plus y square. Okay, so here if we replace x by 0 and y by 0, then denominator will become 0. So whenever denominator becomes 0, then we will have to solve the limit by taking different paths. So here first of all we will take path 1. So limit along path 1. Okay, limit along path 1. So here first taking x tends to 0, then y tends to 0. So this is path 1. First we will take x tends to 0, then y tends to 0. So this can be written as limit y tends to 0 in bracket limit x tends to 0, then function is x raised to 4 minus y square divided by x raised to 4 plus y square. So here if we replace x by 0 in this bracket, then it will be limit y tends to 0. Here 0 minus y square, so it will be minus y square divided by 0 plus y square, so it will be y square. So here it will be minus y square divided by plus y square. So now we will simplify this bracket. So if we simplify this bracket, then y square cancel out. So it will be minus 1, and limit y tends to 0, here it is minus 1. So answer will be minus 1. Okay, so limit along path 1 is minus 1. Because here there is no y, so we cannot replace y by 0. Okay, so answer of limit along path 1, that is minus 1. Now we will discuss path 2. So limit along path 2. Limit along path 2. So for that we will first apply y tends to 0, then x tends to 0. Okay, so this can be written as limit x tends to 0 in bracket limit y tends to 0, then function that is x raised to 4 minus y square divided by x raised to 4 plus y square. Okay, so here replacing y by 0, so it will be x raised to 4 minus 0 divided by x raised to 4 plus 0. So this will be limit x tends to 0, x raised to 4 divided by x raised to 4. Okay, so first of all we will have to simplify this bracket. So x raised to 4 divided by x raised to 4, so it will be 1. So limit x tends to 0 here, and here it is 1. Here there is no x, so we cannot replace x by 0. So this is answer of limit along path 2. So here as you can see that here limit along path 1 is minus 1 and limit along path 2 is plus 1. So both limit along path is different. Okay, therefore we can say that limit does not exist for this question. Therefore limit does not exist because limit along path 1 and path 2 is different. Now we will discuss examples related to continuity. So check the continuity of function at origin, that is 0, 0, and function is f of xy is equal to 2x square y divided by x cube plus y cube for xy not equal to 0, 0, and function is 0 for xy equal to 0, 0. So here we will have to check the continuity of this function at origin. First condition for checking the continuity of function is that we have to check the limit. Okay, so here first of all we will take different paths to find the limit. So along path 1, that is first x tends to 0, then y tends to 0. Okay, so this can be written as limit y tends to 0 in bracket limit x tends to 0, and function is 2x square y divided by x cube plus y cube. Okay, so here we will replace x by 0 in this function. So if we replace x by 0, then numerator will become 0, and here in the denominator 0 plus y cube, so in the denominator it will be y cube. So this will be limit y tends to 0, then here 0 divided by y cube. Okay, 0 divided by y cube. So if we simplify this, then it will be 0. So limit y tends to 0, here it is 0, so final answer will be 0. Therefore limit along path 1 is 0. Okay, now we will discuss limit along path 2. Limit along path 2. So for second path, first taking y tends to 0, then taking x tends to 0. So this can be written as limit x tends to 0 in bracket limit y tends to 0, then function that is 2x square y divided by x cube plus y cube. So here if we replace y by 0, then numerator will become 0, and in the denominator there will be x cube plus 0, so it will be x cube. So this will be 0 divided by x cube limit x tends to 0. So if we simplify this, then it will be 0. So limit x tends to 0, and here it is 0, and this will be 0. Okay, so limit along path 2, that is 0, and limit along path 1 is also 0. Now we will find limit along path 3, that is y tends to mx. Here we will have to find limit along path 3, because in this example limit along path 1 and path 2 is same. Therefore we will have to find limit along path 3. So this can be written as limit x tends to 0 in bracket limit y tends to mx, then here function that is 2x square y divided by x cube plus y cube. Okay, so here we will have to replace y by mx in this function. So this will be limit x tends to 0, here replacing y by mx, so here 2 mx cube, okay, because x square into mx, so it will be mx cube divided by x cube plus, here if we replace y by mx, then it will be n cube plus x cube. Okay, now we will simplify this bracket, so it will be limit x tends to 0, here 2mx cube, here x cube is common, okay, so in bracket 1 plus m cube. Okay, so here x cube cancel out, so it will be 2m divided by 1 plus m cube. Here no need to apply limit x tends to 0 because here there is no x. Okay, so answer of limit along path 3 depends on the value of m. Okay, so limit along all path is not same, because limit along path 1 is 0, limit along path 2 is also 0, but limit along path 3 depends on the value of m, which is different from path 1 and path 2. Therefore limit along path all paths is not same. Therefore we can say that limit does not exist. So if limit does not exist, then function is not continuous. Therefore given function is not continuous at origin, because limit does not exist. Now we will discuss next example of continuity. Check the continuity of function at origin, and the function is xy divided by under root x square plus y square for xy not equal to 0 comma 0, and it is equal to 0 for xy equal to 0 comma 0. So here we will have to check the continuity of this function at origin. So for that, first of all we will find limit of this function. So along path 1, so limit along path 1, that is first taking x tends to 0, then y tends to 0. So we will write down this as limit y tends to 0 in bracket limit x tends to 0, then function. What is function? It is xy divided by under root x square plus y square. Okay, so here we will replace x by 0. So here numerator will become 0, and in the denominator there will be root y square, so it will be y. So this will be limit y tends to 0 in bracket 0 divided by y. So if we simplify this, then it will be 0. So limit along path 1 is 0. Now let us discuss limit along path 2. So limit along path 2, that is first taking y tends to 0, then x tends to 0. So here we will write down limit x tends to 0 in bracket limit y tends to 0, then function. What is function? It is xy divided by under root x square plus y square. Okay, so here replacing y by 0, so numerator will become 0. So here 0 divided by root x square, and root x square, that is x. So this will be 0 divided by x, limit x tends to 0. Now if we simplify this bracket, so 0 divided by x will be 0, and then we will replace x by 0, so answer will be 0. Therefore limit along path 2 is 0. So here, as you can see that limit along path 1 is 0 and limit along path 2 is also 0. Both limit are same. Therefore we will find limit along path 3. Now we will find limit along path 3, that is y tends to mx. So here we will write down limit x tends to 0 in bracket limit y tends to mx. And what is function? It is xy divided by under root x square plus y square. So here first of all we will replace y by mx in this function. So if we replace y by mx, then it will be limit x tends to 0, here mx into x, so it will be mx square divided by in under root x square plus here we will replace y by mx, so it will be m square x square, bracket complete. So if we simplify this result, then limit x tends to 0, here mx square divided by, here x square is common, then under root of x square will be x, so this will be x, and in under root 1 plus m square, bracket complete. Okay, so here mx square divided by x, so it will be mx, so this will be limit x tends to 0, mx divided by under root 1 plus m square. Now we will replace x by 0. So here if we replace x by 0, then this will be 0 divided by under root 1 plus m square, so which is 0. Therefore answer of limit along path 3 is 0. Now we will find limit along path 4, that is y tends to mx square. Here we will find limit along path 4 because in this example limit along path 1, path 2 and path 3 is same, that is 0. So we will find limit along path 4. So here we will write down limit x tends to 0 in bracket limit y tends to mx square, then function is xy divided by under root of x square plus y square. Okay, so here first of all we will replace y by mx square in this function. So this will be limit x tends to 0, here replacing y by mx square, so here it will be mx square into x, that is mx cube, divided by under root of x square plus here it is y square, so if we replace y by mx square, then it will be m square and x raised to 4, bracket complete. Now here simplifying this result, so it will be limit x tends to 0, mx cube divided by, here x square is common from these two terms, so x square is common and under root of x square will be x. So here we will write down x in bracket under root of 1 plus m square, here x square is common, so here it will be x square, bracket complete. Okay, so if we simplify this, here x cube divided by x, so it will be x square. So limit x tends to 0, mx square divided by under root of 1 plus m square x square. Now we will replace x by 0. So here numerator will be 0 divided by under root of 1 plus 0. So this will be 1. 0 divided by 1. So that is 0. So answer of limit along path 4 is 0. So in this example, limit along path 1, path 2, path 3 and path 4 is same and answer is 0 of all paths. Okay. Therefore, we can say that limit exists. So limit exists and value of it will be 0 because answer of all path is 0. Therefore, limit exists and answer of limit will be 0. So here limit of function is 0 and value of function at origin, that is 0, 0 is also 0. It is given in the question. Okay. Therefore, we can say that given function is continuous at origin because limit xy tends to 0, 0 f of xy is equal to 0 is equal to f of 0, 0. Okay. Therefore, function is continuous at origin. So, in this lecture, we have discussed topic that is limit and continuity. Thanks for watching this video. I will see you in the next lecture.